The last question on the test, we have to work out the volume of a frustum, and it tells you quite nicely in the question that a frustum is made by removing a small cone from a similar larger cone. And this word similar is not just used randomly just to say that it looks like it. In maths, similar means that these two triangles share the same proportions, so they've got the same angles but not the same side lengths, this smaller cone and the overall larger cone. And this question is actually quite nice because they've given you the radius, or you can work out the radius of each cone without too much difficulty. You're sometimes asked to work it out, or you might need to work it out using the fact that these are similar triangles. So anyway, let's work out the volume of the larger cone first. I'm just going to call that VL for volume of larger, and that's a third times pi r squared, and r of the larger cone, the radius of the larger cone, is 6. So I know 6 squared is 36, times the height. Now the overall height of both cones, again, don't have to do much work to see that that's 15. Okay, and I can see here that 3 cancels off. Well, I could cancel the 3 with either of these. If I go for this one, there are 12 3's in 36. So this is 12 times 15 times pi. So put that in the calculator. $565.9 to one decimal place. Sorry, 0.5. Okay, and then if I work out the volume of the smaller cone, I use S for smaller. That's a third times pi times the radius squared, and the radius this time is 4. 4 squared is 16, and the height is 10. So on this one I haven't got any multiples of 3 here that I can cancel off with a 3, so I'm just going to have to divide this all by 3 at the end. 16 times 10 is 160 times pi divided by 3. So we've got 160 pi over 3. $167.6. And then the volume of the frustum, as it says in the question, is made by taking away the small volume from the larger volume. So 565.5 minus 167.6 leaves me 397.9. And it's a volume, so cubic centimetres.